Hi, I'm Pat Kelly. Okay, and in this problem, we're asked to determine if this function that they give us, y equals e raised to the minus 2x, is a solution to this differential equation that they give us. So to determine if it's a solution, we're looking to plug it in to the differential equation and see if the differential equation is true. So when I go to plug it in, I can see y equals, I see a place for that, but I also see in the differential equation that I need something to put in for this first term. And the first term is y raised to that parenthetical superscript. What it really comes down to is you have to remember what that notation means. That's asking us for the fourth derivative of y. So I'm going to come over to my y equals and differentiate it until I get the fourth derivative of y. So I'm doing some differentiation on that equation that they gave us. The derivative here is minus 2e raised to the minus 2x. The second derivative, 4e to the minus 2x. The third derivative, minus 8e minus 2x. And the fourth derivative, 16e minus 2x. So we've gotten to the point where we have that fourth derivative of y, so that we're going to be able to plug it in there in the original differential equation. So let's do that, remembering that we're trying to see if that function is a solution. When we plug stuff in, we're trying to see if the equation holds true. So that fourth derivative of y, I have underlined in green, was 16e to the minus 2x. Maybe back to the original pink, we had a minus sign, we had a 16, and then y was equal to e raised to the minus 2x, what they gave us, e raised to the minus 2x, and we're wondering if that does equal 0 in the original equation. Take a look at that equation for just a second, you'll see that it's true. 16e raised to the negative 2x minus 16e raised to the negative 2x does equal 0, so we get a check mark, which means we can conclude that this given function is a solution. Successfully answering the question. Hopefully that helps. Thanks.